guys! Today's video is going to be about three things. Number one, I'm going to review the setup for chemical formulas. Number two, I am going to explain what's really going on at the particle level with a chemical reaction. And number three, I'm going to talk you through the different parts of a chemical equation, which is really the heart of how we can look at what's happening during a chemical reaction as and at the particle level. So if you have any questions, please feel free to ask me about them. Otherwise, let's dive in and check it out. When we're thinking about chemical formulas, I would encourage you to use my two tips that you can see here on the right. Tip number one, look for capital letters, and tip number two, use your periodic table. Because a chemical formula basically tells us the elements that make up a substance and how many atoms of that element make up and help to contribute to that substance as well. So if we go with tip number one, we are looking for capital letters. And if we look at the example here, we can see there's a capital N, there's a capital H, a capital C, and a capital O. All of those capital letters act like dividing lines that separate the different elements. And so that's when you go to your periodic table and you look to see if you can find an element that chemical symbol is Na, and if you were to do that, you would figure out that Na is represented by sodium. If you kept looking, you could find H, and that one you might even know off the top of your head by now that H is represented by hydrogen, C is carbon, and O is oxygen. So now you're going to go back to those two questions. How many elements and how many atoms make that up? So if we look at the capital letters, which links us to tip number one, that's going to tell us how many elements are there. And so there are 1, 2, 3, 4 capital letters, so that means that there are 4 elements that make up this substance. To count the atoms, that is when you need to look at the numbers. We have 1 Na, because it is written there, that means that there is 1. We have 1 hydrogen, 1 carbon, and we have 3 oxygens. We look at that little number behind it to figure out how many there are. If there's more than 1, the number will be written. And so all we need to do then is add up all of these numbers. 1 carbon, 1 sodium, 1 hydrogen, and 3 oxygens is going to lead us to there being 6 different atoms that make up the substance NaHCO3. We are going to take this exact substance and look at it in terms of a chemical reaction. So let's look at this. Let's imagine that our substance NaHCO3 were to combine with HCl, or hydrochloric acid, which we will be doing as an experiment a little bit later on. So I want you to imagine that each of these things here, these circles, are a particle or an atom to represent that element to make up the substance. So it's kind of going back to that visual image of each of these substances. When we have a chemical reaction, we need to imagine that all of these substances are combining, and they are going to be mixed up and rearranged to form new substances, because at the heart of a chemical reaction, that is what's going on. Elements are rearranging and forming new substances. Since we haven't done this experiment yet, I'm not going to tell you what the outcome is, but you might be able to start to figure some things out. Let's first talk about what I have written up here at the top of my page. I have the start of a chemical equation. A chemical equation is basically like a math problem that is written out that shows where the elements go and how they change into new substances. So I have my substance of sodium bicarbonate here, and I have my substance of hydrochloric acid. You'll notice that in between there is a plus sign. That is, just like a math equation, how you separate out the different substances. And this side of the chemical equation is called the reactants, because these are the things that come together and react. Now, instead of a equal sign like you would have in a math equation, a chemical equation separates one side from the other with an arrow going to the right. And this arrow is called a yields arrow, because it yields, and the word yields in chemistry means produces, new products. And that is our mystery side over here. The other side of a chemical reaction is called the products, or the things that are created from the reaction. Now, I'm not going to tell you what those are yet, but I am going to give you some tips to see if you can try to figure this out. We need to imagine when a chemical reaction happens that all of these molecules are coming together and they're going to form out to form different substances. And my first tip is to look to see if you have the right atoms that would make water, because water is often a product, especially in the labs that we do. This is often a product of an equation. And so we need to look to see, are there two hydrogens? Is there one oxygen? Then we can probably guess that one of the products is water from this experiment. And we'll talk a little bit more about how we can see that in real life. My second tip is use your substance table. The table that you worked on, that you went through and you analyzed all of those white substances, there's a lot of chemical formulas in that table, and you can use that to help you try to pick out what other atoms are left, because once an atom is used, it is no longer available to be used again. Whatever we started with on this side will become an atom, or become an atom that is part of a product on the other side of the equation. So all of these are going to be rearranged to form new substances. And we're going to practice this in class through actually doing an experiment with a chemical reaction and then figuring out to determine what the products actually are from that equation. Like how we're going to start with sodium bicarbonate and hydrochloric acid. We will figure out and determine the products that are created from that chemical reaction. So as a review, number one thing from this video, chemical formulas are the key to understanding all of this. If you do not understand chemical formulas, you need to come and see me, because it is very, very important that you understand how many elements and how many atoms make up a chemical formula in order to understand what's really going on at the base of a chemical reaction. Next, when a chemical reaction occurs, new substances are created because of this reaction, and we see that through signs of chemical reactions, like color changes, or bubbling, or fizzing, or expansion of objects into something else. So we have to remember that what we start with isn't always what we end with, and we can explore that through a chemical equation. We need to remember that chemical equations are kind of like a math equation. They use plus signs, and instead of an equal sign, it uses an arrow that means yields, and that it has two sides. It has the reactant side and it has the product side, the things that are produced as a result of the experiment. Let me change that word to product. Can you read that? Let me try again. Product. That's better. We have the reactant side and the product side. All of the reactants are separated by plus signs, and if more than one product is created, it is also separated by a plus sign. We will get more into this next week when we observe and look at it closer at the particle level. But if you have any questions, please ask. These are the three main things from this video, and we will discuss and review in class together. Please take a second to answer the question on the learning survey below.